Okay, so let me start solving the answer. Anybody else other than Somesh got the answer? Okay. Okay, let me solve the question. Okay, so this involves Parseval's theorem and one more simple Fourier transform pair you should remember. So let's start solving the problem. So now we need to find out five t dt. So what is sinc t? Sinc t is defined as sine pi t by pi t. I've already told you one expression, one famous Fourier transform pair, which you need to remember. Which is sine at by pi t. When you take Fourier transform, you will be getting a rectangular waveform which is going from minus a to a in the omega domain, frequency domain with amplitude 1. Let us have this as x of t. On taking Fourier transform, you will be getting a rectangular pulse which is going from minus a to a with amplitude 1. So now our interest is to compute what is the value of, like literally what is the energy of sinc phi t. In other words, what is the expression for x of omega? Like what is the definition of Fourier transform? It goes from minus infinity to infinity. If you are finding a Fourier transform of a particular signal x of t, you will find it like this, minus j omega t dt. So one way is finding out the Fourier transform of sinc square phi t and putting omega to be 0. When you put omega to be 0, what you will be getting? We will be getting the area under the curve x of t, where in our question x of t is equal to sinc square phi t. So what is sinc square phi t? Sine square phi pi t by phi pi t. No, sorry. We need not write it like this. Yeah, we can have it as sine phi pi t by phi pi t into sine phi pi t by phi pi t. This is what sinc square phi t means. Okay. So this is in the time domain. Let us have this as x1 of t and this as x2 of t. Right. So in time domain it is x1 of t into x2 of t. So in frequency domain it will be the convolution between two rectangular pulses. So now sine phi pi t divided by phi pi t gives you a Fourier transform, like substitute a to be 5 pi here and divide it by 1 by 5. Okay, let me go step by step now. Sine phi pi t, substitute a to be 5 pi. What you will be getting? A rectangular pulse which is ranging from minus 5 pi to 5 pi with amplitude 1. Right? This is the Fourier transform x1 of omega. Similarly, if you are computing 5 pi to 5 Fourier transform, these two are identical here. However, for understanding purpose, I am having it as x1 of t and x2 of t, and this is x2 of omega, right? So now we need to multiply, like we are having a 5 extra factor here, so let's divide 1 by 5 on both sides. So now we need to multiply in the time domain, so it becomes convolution in the frequency domain. What is the formula? x1 of t into x2 of t. When you take the Fourier transform, it will be 1 by 2 pi into x1 of omega convolved with x2 of omega, right? So you have two rectangular pulses minus a to a with 1 by 5, sorry, minus 5 pi to 5 pi convolved with again one more rectangular pulses. This is x1 of omega, this is x2 of omega, and this is equal to minus 5 pi to 5 pi, right? So now what you will be getting, you know how to convolve two rectangular pulses, right? So when you will be getting a triangular pulses, because both these rectangular pulses are identical and they are going from the same x-axis value frequency and ending at the same x-axis frequency with the same amplitude. Means like when you are convolving two identical rectangular pulses, you will be getting a triangular pulse, whereas if you are convolving two non-identical rectangular pulse, you will be getting a trapezium, right? So the starting point of the triangular pulse will be the sum of these two, that is minus 10 pi, and the ending is the end point is the 5 pi plus 5 pi, which is equal to 10 pi. And what is the amplitude? Amplitude is nothing but computing the area of these two. Means like you need to multiply and compute the area. So when you are multiplying, what you will be getting? You will be getting an amplitude 1 by 25, and which is going from minus 5 pi to 5 pi d omega. This is the value of, let us have it as y of omega, so where y of omega is equal to x1 of omega convolved with x2 of omega. So if you are doing this, what you will be getting? You will be getting it as 10 pi by 25. Amplitude at omega equal to 0 is equal to this value, 10 by 25. How you are getting this value? You need to compute the area under the multiplication between the two curves. Area under, like, how am I saying is, this is the peak amplitude which you are getting, right? So now you need to compute the area of coverage between these two functions, x1 of omega and x2 of omega. So since they overlap exactly, since they are going from the same starting point and ending at the same ending point, you need to calculate the area under the multiplication of these two curves. So that's why I have put like 1 by 5 into 1 by 5. You are going from minus 5 pi to 5 pi. So amplitude is 10 pi by 25. In addition to that, you have 1 by 2 pi factor also. So you need to plus 1 by 2 pi. Right. So now we need to compute what is the value of minus infinity to infinity sec square of 5t. So that means we have x of t to be sec square of 5t. From there only we started doing this and all. Right. So we need to find at frequency value 0, what is the value of the amplitude? Like what is the value of the convolution between two of the Fourier transform of sec 5t. So when you are doing that, let us represent it as y of 0. You will be having it as 10 pi by 2 pi into 25, which is equal to 5 by so you will be getting 1 by 5, which is equal to 0.2. Your answer should be 0.2. It's not pi by 5, it's 0.2. Everyone got what I said here? So I'll give a quick recap. So Fourier transform pair, I've told you that keep this in mind because this is a very important transform pair which you need to keep in mind when you get questions as such in the question paper when you're writing the exam. If sin AT by pi t, it gives a Fourier transform of minus a to a in the omega domain. You need to keep this very carefully because in frequency domain you will be getting the same rectangular pulse, but it starts from minus a by 2 pi to goes to a by 2 pi. So this is in the frequency domain. Okay, so this transform is for omega domain. So now we need to compute what is the Fourier transform, what is the energy under the curve sinc phi t, or we need to compute what is the area under the curve sinc square phi t. So in order to compute this, what we need to do is we need to compute the Fourier transform. The step 1 is like Fourier transform of sinc square phi t, and then have it as y of omega and then put omega to be 0. The second method can also be done like this. You can take the Fourier transform of sinc 5t. Okay, I'll write it. I'm writing the second method here. This is one more method which you can follow. So second method is like this. Okay, so what you can do is you can find the Fourier transform of, you know, Parseval's theorem, right? So what is Parseval's theorem? Minus infinity to infinity x of t the whole square dt, which is equal to 1 by 2 pi. It goes from, again, it is a periodic signal, is it? No, it is a continuous time. So x of omega the whole square d omega. This should be the expression, right? So the thing is, you can compute. See, the given expression minus infinity to infinity sinc square 5t can be written as minus infinity to infinity sinc 5t the whole square dt. So if you are writing it in the Parseval's theorem, hello, yeah, if you are writing it in the Parseval's theorem, what you need to do is, I think I left 1 by 2 pi somewhere here. So it should be 1 by 2 pi coming in front. Am I right in this expression? The Parseval's theorem. Let me check once. Okay. So 1 by 2 pi should be there, right, Somesh? Yeah. So we are averaging it over 2 pi. So this is power, right? Parseval's theorem is comparing power. Right. Okay. So what you can do is you can take the Fourier transform of sinc 5t and compute its energy. You can do this way also. How you can do this? Sinc 5t is equal to sine 5 pi t by 5 pi t. So we know that what is the, just now I told you, this is minus 5 pi to 5 pi, 1 by 5, this is omega. So let us have it as x of omega and this is x of t. Right, you need to find the energy under this curve. How do you find the energy? This from This from energy is equal to 1 by 2 pi minus infinity to infinity x of omega the whole square d omega. So 1 by 2 pi integral from where to where? Minus 5 pi to 5 pi with the amplitude 1 by 5 the whole square d omega. So what you will be having? 1 by 25 into 10 pi divided by 2 pi, which is equal to 0.2. So anyway, you'll be getting the same answer. The second method is a bit easier compared to the first because you need not go into convolution finding out the peak value or not. It's easier to do this. So you can either follow the second method or first method. Both will yield the same answer. So got it? Why is it 0.2? Anyone have any doubts? So you can follow either one of the method. But whenever these type of questions are given, go by passive algebra. Don't go by the first method. Got it? Is it clear with everyone? If you have any doubts, please let me know. So can I go into the next question? Can I get some answer from the present students? Okay, only Somesh is answering. What about the others? Being a bit more interactive? Yeah, cool then. Okay, let's go on to the next question. Let's see. So, this question is done. Okay, let's go on through with this question. Let h1 of z be 1 minus p z inverse the whole inverse and h2 of z be 1 minus q z inverse the whole inverse, and h of z is equal to h1 of z plus r h2 of z. The quantities p, q, r are real numbers. This they have given. They told that p is equal to 1 by 2. This is 1 by 2, don't get confused. Q is equal to 1 minus 1 by 4. And this r which they have specified here is mod r is less than 1. So if the 0 of h of z lies on the unit circle, what is the value of r? So this is one of the gate question. Try to solve this question and start grasp the idea of whatever this question says, and then just think about how this can be solved. No need to solve it numerically and get the answer. This is quite a bigger problem. So you can think upon what method can be used here, so that when I solve, you can understand it much more easily. Okay, it's more of involving algebra. So let me take over the question and start solving. I guess you would have. It's quite a easier problem, but it involves more calculation. But you can try with me parallelly with the. So what they told is h1 of z is equal to 1 by 1 minus pz inverse. h2 of z is equal to 1 by 1 minus q z inverse. h of z is equal to h1 of z plus r by 1 minus q z inverse. They told that p, q, r are real numbers and 1 minus half z inverse plus r by 1 plus 1 by 4 z inverse. So okay, the remaining part of the question comes, we can have it like, we can use the remaining part of the statement after simplifying this, right? So cross multiply it, what you will be getting? If you're getting the answers, you can post it in the chat box. Let's see who does that first without any calculation mistake. So you get 1 plus r plus 1 by 4 minus r by 2 into z inverse, right? Divided by some denominator. Do not worry about it because the next part of the question only involves the zeros, right? So they say that the zeros of h of z, it's lying on the unit circle. So that means the root of this equation is nothing but z is equal to 1. You can have it like this because any point in the unit circle, if any point in the unit circle can be the root of this polynomial. So for example, if you are taking z to be 1, for example, they say that if the zeros of h of z lies on the unit circle, and they say you need to look into the statement very carefully. Okay, let me turn it like this. Probably this will be good. Okay. Yeah. So 0 of h of z lies on unit circle. Okay. So there can be many possibilities. If the 0 lies on the unit circle is like this. This is z is equal to 1. So there can be there can be roots in any of the points that is present in the unit circle. But what they have said is, they have said p, q, r are taking the values to be real. They are not taking any imaginary values. For now, if you are taking z to be equal to 1 and z to be equal to minus 1, these are the two values that gives us the real values. So what is that? Let us compute the root of the numerator. That is the 0 of the transfer function h of z. So what you will be getting? Z is equal to r by 2 minus 1 by 4 divided by 1 plus r. So first case, let z to be equal to 1, r by 2 minus 1 by 4 divided by 1 plus r. So what you will be getting? R to be equal to you will be getting some 5 by 2. In the second case, if you are putting z to be minus 1, what you will be getting? This gives you a value of r to be minus 0.5. But we have a condition. If you are looking at the question, we have a condition. This r should be less than, mod of r should be less than 1. So if you are taking the last two values, namely r is equal to 5 by 2 and r to be equal to minus 0.5, you find the mod r to be equal to 0.5, which is less than 1. Right? So we go for the second option. So what is the question? R should be minus 0.5. This is the answer, because with any other values of z, it can be imaginary. Like if you are having this j is equal to r by 2 minus 1 by 4 divided by 1 plus r, j is lying in the unit circle. But when you are solving this, you will be getting a value to be some imaginary value, but this is not allowed as far as the question says, because in question they have clearly implied that this r, p, q and all should be taking real values. So that's why we are constrained to only two values. We are considering only two values. That's why that is because the value of r should be considered as real. So when you're taking z is equal to 1, you get 1 r value, and when you're taking z is equal to minus 1, you get another r value. But when you are comparing these two, only one of these values satisfy the condition that is given in the question, that is mod r is less than 1. So therefore, the answer of r to be equal to minus 0.5. Okay. Shall we move on to the next question? Is this question clear? Can I get an acknowledgement? So, is it clear, or I need to explain it? Yeah. So, Bunty says it's clear. What about the others? Rest of like 9 of the other members? Shall I assume it that you have understood the question and answered whatever I've solved now, or Amruta, Kamali? Okay, good, Ashi. Okay. So let's move on to the next question. So this is one of the easier question. So let's go on to this question. What is this question? So they say that the DFT of a vector A, B, C, D is the vector alpha, beta, gamma. What is this? Okay. So DFT So the DFT of this ABCD is equal to some matrix they have given. Now they have defined some other matrix PQRS with some relation between ABCD and one more matrix. Right. So they are asking what is the DFT of the vector PQRS? Is the scaled version of. So they are saying the scaled version. Scaled version means some alpha into the answer option which they have given. This alpha can be any scalar value. Okay. So let's try solving this question. Try getting some idea on this PQRS, which is having a relation between ABCD and the matrix ABCD. Some relation is involved between these two products. Try analyzing it. You'll get the answer. Okay, I'll move on with the answer. Okay, let me move on to the next, the answer. How many of you in this meeting know about circular convolution? Can I get an acknowledgement? How many of you know about circular convolution? Bunty, Neetu, do you know about Ashi? Do you guys know about circular convolution? Okay. So you guys know about the matrix multiplication method, right? Like, let me do this for you. So, circular convolution can be done in various ways. One way is like when you're having a vector 1, 2, 3 and 4 and having another vector namely 3, 5, 6, 7. You can compute the circular convolution between these two vectors by rotating one of the matrix and forming a 4 by 4 matrix. Sorry, rotating one of the vector and forming a 4 by 5 matrix and multiplying with the another vector. How can you do this? It's like 1, 2, 3, 4. Write the first vector as it is and then shift, like rotate by one location. It goes here, it comes here, it comes here, it comes here. Similarly, it goes here, this comes here, this comes here, this comes here, it goes here, and again the same matrix will become 1, 2, 3, 4. So this is a 4 cross 4 and you need to multiply it with 3, 5, 6, 7. And the resulting vector x1, x2, x3, x4 is the circular convolution between x and y vectors. Right, this is the matrix method. Okay, so I hope you guys know about this method of computing the circular convolution between two vectors. So now, when you're observing this matrix, you can find one relation. What is that? Can anyone find it? What is the relation between the circular convolution and the relation that is given in the question? Can anyone compute it? Guess it? Okay, no problem. So you have this expression, right? P, Q. Good, good. Yes, circular convolution of A, B, C, D. Right? A, B, C, D. You have A, B, C, D. D, A, B, C. C, D, A, B. B, C, D, A. Right? Now, take transpose on both the sides. If you're taking transpose, the row vector becomes the column vector. See, A is equal to CD. If you take A transpose, this becomes D transpose, C transpose. Oh, okay. Sorry. The question is, sorry, I wrote the matrix wrongly. This should be A, B, C, D, D, A, B, C, C, D, A, B, and B, C, D, A. Right? So take the transpose. What you will be getting? D transpose. So you need to take the transpose of this and write it here. A, B, C, D, D, A, B, C, C, D, A, B, B, C, D, A, and then you should take transpose and write it here. So now you can compute that this first relation and the star relation which I have described here, both are same. So that means this is nothing but ABCD circularly convolved with ABCD. Okay, this is something which you need to remember. So now, if you are taking DFT on both sides, they are asking what is the DFT of the vector PQRS. So if you're taking DFT on both sides, the DFT of PQRS is equal to DFT of ABCD into, so circular convolution in time domain will be reflecting as DFT multiplication in frequency domain. So this they have given in the question, which is equal to alpha, beta, gamma, delta, and it is multiplied with, if you are multiplying it, what you will be getting? Alpha square, beta square, gamma square, delta square. So this is the answer. The answer should be A. Got it? This is quite a simple question, but you need to know the concept of circular convolution. Okay, can I move on? Which matrix form you are talking about, Panti? The expression one which I have written here, or this one? Okay. What is this? Can you explain this matrix multiplication at last? This one. Okay. So this is not a matrix multiplication. This is a vector multiplication. So when you are multiplying two vectors, the multiplication will happen correspondingly, like position wise. Alpha into alpha, the first position alpha into alpha, the second position will be covered by beta into beta, and third is gamma into gamma, and the fourth is delta into delta. So that's how a vector multiplication happens. So it will happen as element wise. It's not a matrix multiplication. Okay, so Bunting asked about the matrix form. See, okay. So if you are having some x is equal to a, b, c, d. Let me take the same example. No, like let me have it as different alphabet: E, F, G, H. So if you need to find, this is one of the effective method which you can do to compute the circular convolution. Okay, so x is equal to a, b, c, d means x. See, circular convolution, you know linear convolution. If x is of length L and y of length M, z, which is equal to x convolved with y, will have a length of L plus M minus 1. This is what linear convolution. When you go for circular convolution, then x is of length L and y is of length, y should be of length L, and then when you circular convolve x with y, the length of this will also should be L. Okay, so that's why you go for overlap, save method, add method to replicate whatever is done in the linear convolution. You need to convert circular convolution to linear convolution through those methods. Right, so now when you are circularly convolving x and y, how will you do that is, take any one of the matrix, either it can be x or it can be y. Take one of the matrix. They would have, see, vectors can be of row or column, whatever it is. Take this as A, B, C, D, stack it up in the row, column side, then shift it, rotate it by one location. How will you do this? Have it A, B, C, D. The next should be D, A, B, C. How this is happening? This D should come in the first space, A should be coming in the second, B should be coming in the third and C should be. Similarly, rotate it like this. C, D, A, B. Rotate it. B, C, D, A. You get a 4 cross 4 matrix. So whenever you are having a vector of n side n length, it should form a matrix of n cross n. And you need to multiply with the next vector E, F, G, H. If this is a 4 cross 4, this should be of 4 cross 1. So you should stack it up, stack the row vector in the column vector form. And the final answer should be 4 cross 1. So that will be equal to x1, x2, x3 and x4. So when you are doing this is an ordinary matrix multiplication. Now you will be getting a 4 cross 1 matrix, which will be now this is the resultant of circular convolution of 2 vectors that is given in the question. So now if we are going here, we have some random relation between PQRS and ABCD. But this seems to resemble something like a circular convolution. So for that to happen, just take a transpose. This should be a column vector. If you're taking transpose, I told you, take it as a D and E, take it as A. So A transpose is equal to E transpose D transpose. This A transpose is nothing but you are taking the transpose ABCD, DABC, CDAB, BCDA into D transpose ABC. Now if you see Bunty, this is resembling what I have told you now. Meaning EFGH you can have it as ABCD itself. So if you're closely watching, the one which I have told here and the one which I explained here is the same. So that means this is nothing but ABCD circularly convolved with ABC. Right. So circular convolution in time domain, you know it's multiplication and frequency domain. So DFT of ABCD into DFT of ABCD, which is what I have written in the last line. Like last line, I've multiplied. Vector multiplication, it's like element wise, it happens element wise. You need to just multiply between the vectors, like element wise. The first element should be multiplied with the second element, like that. Got it? Yeah, that will also result the same. It will follow the commutative property. Circular convolution will follow, like similar to convolution. Convolution follows commutative property, right? So if even you take circular convolution of y and y circular convolution of x is both the same. It follows commutative. Just take the reverse and start multiplying. You will understand why it is so. Got it, Panti? Are you satisfied? Okay. So we'll move on to one another simple question and wind up the class. Okay. Let's go on with this. So consider a discrete time signal x of n is equal to n for 0 less than or equal to n less than or equal to 10. It's a discrete sequence. So y of n is the convolution of x of n with itself. The value of y of 4 is. Try solving this. Some simple question on convolution. by solving it. Let me give a start to this question. Just plot it. Because it's just 0 to 10. Just plot it. 1 for 1, 2 for 2, 3 for 3, 4 for 4, and it goes on up to 10. The amplitude will be 10. This is for x of n. Now have it as x of k. Right, what is the convolution formula you know? Y of n is equal to sigma, k is equal to minus infinity to infinity, x of k, h of n minus k. So here h is nothing but x itself, because the question says x of n is convolved with itself. So x of k, h of n minus k. Now they are asking us to find what is the value of y of 4. X of k, h of 4 minus k. So how do you plot this? This is nothing but x of 4 minus k. You have x of k. How do you plot x of 4 minus k? It's quite... You can go on with summation. You can expand this. Like go on for substituting k equal to 0, 1, 2. Like that also you can go. If you do that, because x is nothing but a causal sequence. So it will have, you can write it as k is equal to 0 to infinity x of k into h of n minus k. It's like 4 minus k. This is x because the convolution between the same sequence. So now if you're doing this, what you will be getting? X of 0 into x of 4 plus x of 1 into h of x of 3 plus x of 2 into x of 2 plus x of 3 into x of 1 plus x of 4 into x of 0 plus x of 5 into x of minus 1. This is not possible because x is a causal sequence. So we have x of 0. This is 0 obviously, because x of, for 0 it is taking 0. Because for 0 it is 0, 1 it is 1. That's why I plotted a sequence like this. So at 0 it is taking a value of 0, plus at 1 it takes a value of 1, 2 it takes a value of 2, 3 it takes a value of 3. It's a ramp sequence. And again 0. So what you will be getting is the final answer to 10. Clear with this? You know how to go on with convolution and then compute the value of whatever the value they are asking for. For example, if they are asking for y of 0 or y of 1 or y of 2, just substitute in the formula that is the standard formula that is given in the textbook, and then go for either the graphical method or just substitute in the summation depending upon the question. Means like if question is having a very smaller sequence, for example for like a finite sequence for just 0 to 4, or for n occupying the value from 0 to 5, like that very small sequences, you can go for the summation method. Just now I followed it. If it is a very long process, for example, they have given some e power minus t into u of t and convolved with e power minus t into u of t, and they are asking what is the value of t equal to 0, what is the value of the convolution result, then you can go on with the graphical method, because that's easier than going for this kind of summation or something like that. Or you can, if it is a discrete type, you can even go for matrix, the method, the simpler tabular column method, which usually people follow for computing the discrete sum, convolution sum. Okay, so I guess the remaining questions will cover in the next class. I'll however take this week solved. Just be solved. So this question is, these questions are there. In addition to that, I will add few more questions and come back to the next class. So meet you on next Monday. I hope you copied the answer for this. Yeah. Anyway, as I've told before, even if you're not aware of this formula or something, you can go on reading. Question 60, 2022. I think that's all I covered. Sixty is the control system question, right? But I have handled this question in the phase 1 class itself. Anyway, now, yeah, this question I've covered previously. Okay. What is it? The block diagram. Okay, so okay. Anyway, we are nearing the time. This I'll cover in the next class party. Yes, recording. I don't know whether it is available. Yeah, but I have covered this question in the phase 1 term itself. But that's fine. I'll cover it in the initial 5 to 10 minutes of the next session. Yeah. Thank you for joining the class. You can leave the class. We'll meet next Monday at 6. Thank you. Thank you. Hope the session is useful.